Hi everyone, how are you today? Today we're gonna back to Calculus 1. Some of the students, they asked me to explain the concept of the first derivative and what we can get from the first derivative. The first application about the first derivative is to find the critical point, increasing, decreasing intervals, the extrema point, the maximum and the minimum points. Okay, let us see what we can do there. Let us see. Let me just before I start to remind you, if you have any question, you can send me a text for any topic you need help, or you can go to our email, send us an email for your concern. At the end, don't forget to like and subscribe our videos. Okay, before I start, I'm gonna open my boards to be ready for you guys. Okay, this is our class. Okay, and let me open the other board, which is gonna help me to explain my concept. Okay. First, what I used to do to explain what I mean by this is what we need to discuss for the first derivative. To find the critical point, increasing, decreasing interval, extrema, maximum, and minimum. The extrema, if you ask you to find the extrema mean maximum and minimum. The maximum and minimum could be local, could be absolute. The maximum value in your, when you find the maximum and the minimum, you plug them back in the function, and you see which one give you the maximum value, which is what you want. Look. Now, I know most of the students, they like steps. Critical point, the point on the graph at which the tangent is horizontal or vertical. Horizontal mean, I need to remember this, the first derivative equals 0. Any x values make the first derivative equal 0, give you a horizontal tangent, which is the slope. And remember, f of prime of x now, it's slope. The slope of the function, another way to find the slope. Another critical point we can find when the derivative does not exist, any x values. When you plug it in the derivative and give you undefined value, because it does not exist, also count as a critical point. Polynomial functions, which is always continuous, we have no problem with it. Have three types of critical points: maximum, minimum, and point of inflection. The point of inflection related to the second derivative. Okay, increasing, decreasing. From the graph of the function f of x, see where the graph of the function going up, it's increasing, or going down, decreasing. From the graph of the first derivative, if you give the f of x, just you watch. I have some example. From the graph of the first derivative, you see f prime of x look a bit different. Watch here. When the graph of the function above x-axis, that means increasing. When the graph below x-axis, is decreasing. Okay, I'm gonna stop here, then I'm gonna back here. I'll see the graphs. Okay, let me discuss the graph with you. Okay. Let me discuss the graphs I have some graphs here for f of x. Then after that, we will go to okay. Let me just take this, and take this. We have only this graph, right? Look, if he asks you to find this graph, where it's increasing, where decreasing, and what the minimum or maximum value, the extreme values. Look, I'm gonna take this point, which is 2 and 2. Okay, 2 and what? 2 here, this point. Okay, now let me just show you something what I mean. This f of x, this function f of x, and this is f of x. See what I'm gonna do now. Okay. Okay. If he gives you this graph of the function f of x, the function going down here, decreasing, negative, 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 from negative infinity to the 2, x on, right? Then after that, the function start to increase. Increase. This f of x, right? F of x, remember, right? Now, from here to here, from 2 to infinity is increasing. Increasing. Okay, good. Then from negative infinity to the 2, stop at 2, decreasing. Then after that, increasing. Okay, good. I'm going to show you something else. Now, this is for f of x. Good? This for f of x. At 2, it's a horizontal tangent. It's a horizontal tangent. Look here, at 2. Okay, I'm going to do this. And back to this graph. I'm going to graph, I left space here, x, y equal 2. Y equal 2. Y equal 2. Look here, the blue line. Then we have an extrema point at x equal 2. Because the line here is what? And the derivative at this point, because the tangent line at x equal 2 is horizontal, mean the derivative f prime of 2 equals 0. F prime of 2 equal what? 0. Then f prime of 2 equals 0. Why? Because the tangent line is horizontal. Good. Look, I need you to understand. We said for the function itself, we see where the function going down, it's decreasing, going up, increasing. Okay, I'm gonna go there. Let us believe, make believe, this is not, this is f prime of x, not f of x. To understand what I mean, let us believe this guy is f prime of x. F prime of what? F prime of x, not f of x. Since all the graph above x-axis, since, let us believe this f prime of x. If the teacher changed his mind and in the test he told you this is f prime of x. This is f prime of x. What this mean for you? The function always increasing from negative infinity to positive infinity. Why? Because all the graph of f prime of x above x-axis, above x-axis. Then, if this guy, derivative and above x-axis, this mean we talking about all the function is increasing. Look here, we use f prime of x to discuss the behavior of f of x. F prime of x guide us how the function f of x behave. Okay, let me just see another graph. Okay, let me just take this out and see the second one. Good. Okay, we don't need this. Let us go to this one. See how this is graph. Oh, it is here. This guy here, right? Negative x, right? This guy. Okay, this guy, f of x, if this is f of x, let us discuss the two cases. If this function is my f of x, this is this point, if you see, this point is -1 and -3. This point, -1 and -3. You have to find it, okay? The function going up, positive, 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 all the way to here, right? Going up, going up. Then from -infinity to -1, increasing. Why? Because if you go back to the rule, okay, you will see when the function going up. And here, the function going down. And this going up, going up, going down. Then from -1 to infinity, decreasing. If this f of x, this f of x, good. And we have a horizontal tangent line, a horizontal here, tangent line at x equal -1, then that means for me f prime of -1 equals 0. F prime of -1 equal to 0. This is okay. Now let us make believe this is not f of x. This is f prime of x, and see what we can do from this. Okay. Then this is f prime of x. What you see, as if you follow my rule, all the graph of f prime of x, all the graph of f prime, this f prime of x, all the graph is below x-axis, then all the graph is below the negative, then this always decreasing. If the teacher, he told you, this is the graph of the first derivative. Since everything below, decreasing all from -infinity to +infinity. Good. Let us take another example, right? Let us take another example to see what we can do. Just take this out. We don't need you guys. Okay, let us go delete this, go to this. If this is f, let me just take this point here. Let me graph the point -2 and 2. -2 and 2. Just watch me this further, okay?
Are you aware?
Yes, no problem, you can talk, yes. I have one of my students here, and he's willing to help me here, right? -2 and 2. And let us graph a line x equal -2. See, x equal -2. You see, at x equal -2 here, at x equal -2 here, at x equal -2 here, right? Right? At x equal -2, we have a vertical line, right? Let me just discuss this. Now, let us say this guy is what? My function, f of x. My function, f of x. My function, f of x. I know that here, f prime of -2 does not exist. Why does not exist? It's what? It has a vertical line tangent at x equal -2. And this is from algebra. Any vertical line has slope. The slope of the vertical line is undefined. The slope of the vertical, say that, the slope of the vertical line is what? Raise your voice.
The slope of the...
Which is mean the first derivative does not exist at this, which is true. That's what we explain. And watch, the function is increasing from negative infinity to positive infinity. No such what? Increasing from negative infinity to positive what? Infinity. No maximum, no minimum, nothing. This is as a function of x. Now let us make believe that this is not my, let us believe this is not my f of x, f prime of x. Okay, good. Then I don't need this guy. Okay. Now he's telling me this guy is what? F prime of x. No, just let me just take it a little bit up because, okay, I need to see here. Okay. Okay, good. 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 Okay, this f prime of x. Now in the test he told you if the given graph, if the graph of the f prime of x, the graph of f prime of x, find the increasing, decreasing, maximum, minimum. Look, the rule, when the graph below x-axis is decreasing, above increasing. Look, the graph, look like below, minus, 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 negative, 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 till 3. Then after 3, what is above, right? Positive. This f prime of x now. All the graph is what above, right? Then it's good to draw a number line and put in